Okay, so today we're talking about compound interest. So compound interest is one of those topics that's actually going to come up in your real life in the future. If you ever put money in a savings account, or if you ever open a certificate of deposit, if you ever invest in mutual funds, things like that, your money's going to grow according to compound interest. On the flip side, if you ever take on any debt, take out a loan to buy a house, or you get a credit card or something like that, that debt, the amount that you owe the bank, will be calculated according to some compound interest formulas, okay? Now, you're probably not going to have to sit down and calculate this stuff by hand, but it's good to understand kind of how it works so that you know sort of what's going on with your money in the future. So here's the formula. Looks kind of complicated. There's a lot of variables going on in here, so let's take a look at it for a little while and make sense of it. So I've labeled out what all the variables mean down here, okay? So we got A equals P times the quantity 1 plus R divided by N, all to the power of NT, so this NT is an exponent. Okay, so A just stands for the current amount of money in your bank account, or the current amount of money that you owe the bank. P is the principal. It's just a fancy word for saying the starting amount. You'll notice that the formula has this 1 plus, and then we have this R over N, where R is the annual interest rate. It's always going to be expressed as a decimal. Don't ever just put like a whole number percent in there. It's going to make this thing way too big. Then you'll see this letter n, the variable n, shows up in two places, down here in the denominator of this fraction and also up in the exponent. So what that n stands for is the number of times compounded per year. And compounded is just a way of saying that the bank is calculating interest on your money. So sometimes they calculate the interest every day. Sometimes the interest is calculated every 3 months or quarterly, 4 times a year. They do it every month. So, it's different according to different problems, different situations. And then t is the number of years. So if you look at this equation, it has the structure of an exponential equation. So we have the starting amount times this growth factor to an exponent. And I know that this is growth because of this 1 plus part. So hopefully you guys know that when you add a number to 1 and get something larger than 1 and then raise it to a power, this is going to create exponential growth. Okay, so this is sort of the exponential growth formula for compound interest. Let's just do a couple problems and see how it works. Okay, so an investment account pays 5.4% annual interest compounded quarterly. If $4,000 is placed in the account, find the balance after 8 years. Okay, so a lot of stuff to deal with here. What I would recommend is just kind of run through the problem, taking a look at this formula, and just writing down what we know. Okay, so the formula starts with A. So A equals what? A is the current amount of money in the account. It says find the balance. So that's what we're looking for. So we don't know that one. Okay. Next up, let's see if we are given P. So P is the principal, the starting amount. Okay. So the starting amount is how much I'm going to open my account with. Here it is, $4,000 placed in the account. So P's 4,000. Okay. Next up, we get this 1 plus. This is always 1 plus. I don't need to think about that. Next thing I come to is this R on top of the fraction. Okay. R is the annual interest rate. So I want to think about what my annual interest rate is. So it says right here, I've got 5.4% annual interest. Now I want to be careful. I'm not going to say R is 5.4. That is wrong. We got to turn that into a decimal. So we have to use 0.054 for our annual interest rate. Okay, next up we come to this n on the bottom of the fraction, and we see that n is the number of times compounded per year. So we look in the problem, how many times are they calculating the interest or compounding? Here it is, compounded quarterly. Okay, so quarterly means that they do it 4 times a year. There are 4 quarters in a year, 4 quarts in a gallon, 4 quarters in a dollar. Okay, and so then the last thing we got to do, the n shows up in the exponent as well. Now we just need to look for t. T is the number of years that we are waiting to let our money grow. And there it is, so 8 years. Okay, so there's all the numbers that we need to be able to solve this problem. So the last thing, or the next thing to do is just to put it into the format of the formula, okay? So let me get an equation going here. So we got A equals, and we want to put in our P number, okay? 4,000. Then we always have 1 plus, okay? Then we want to put our interest rate, 0.054, remembering that it's a decimal. Don't put 5.4 in there. Now on the bottom we put our n value. N is 4. Okay. Close up our parentheses here. And then in our exponent we've got n times t. So n is 4, and we're going to multiply that times 8. Okay. And so then we just have to basically get our calculator out and type this thing in. Fortunately, if we have our TI-84 calculators, this thing's going to do the work for us, so we don't have to do a whole lot of work at this step. Okay, so we just put in what we just typed in, and you can type it in just like I typed it on the screen a moment ago. So 4,000 times 1 plus, and then to get my fraction, I'll do alpha y equals 0.054 over 4. Okay, to the power of 4 was in times 8 years, and poof, this thing is going to do the work for us. Okay, so it turns out that after 8 years, our $4,000 grows to $6,143.56. Okay, so 61.43, about 61.44 if we want to round it off. Okay, so $6,144 is how much is in our account after 8 years.